Okay, so this is our last graph type, so 1 over x. So the way that this looks is we've got asymptotes. This is right on the axis, but you can't draw the line right on the axis, so the little dotted line, you put it slightly off so you can see it. That's the vertical asymptote is the one that goes up, and that's going to be x equals a number. In this case, it's x equals 0. And your horizontal asymptote is going to be y equals a number. So as soon as you see x is on the bottom of the function that you need to graph, it's going to look like this. So the graph is called a hyperbola. And that's what it looks like. So it has two pieces separated by these asymptotes. So how do you draw this? So all the other ones had like a vertex, an important point, and then you knew the shape and you drew it from there using your intercepts. This one, you have to draw the asymptotes first, and then you put these two shapes in it. So what do these actually do? This is saying it goes along this. This is the y equals 0. We're not up or down. It approaches the 0. The bigger x gets. Up here it goes to infinity. Negative infinity down here, and this would be approaches 0, approaches 0. And that's what it does. Now, what are these points? Like if we were looking at a table of values for this, which is not how we're graphing, but you can always do it. I remember when I took these transformations and drawing the graphs by memorizing what they look like, I always did, just as a check, a little table of values on the side, made sure my points were right. Because you can always draw a graph with a table of values. When we did lines, remember we had x plus y equals 4, and we were listing points. What points work in x plus y equals 4? 2, 2, 3, 1. Those are all points you could plot. You don't need that many, but you can do that. So what if we plug 0 in? What happens? It's not possible. That's the asymptote. So this is undefined, right? You can't divide by 0. Vertical asymptote. What about 1? What do we get? 1, 2. Let's put it as a decimal, 0.5 or 1/2, right? 10. What if we put 10 in there? What about negative numbers? Negative 1, what do we get? 1 over negative 1. Negative 2. Negative 0.5. Negative 5. I could do 10, but what's 1 over 5 as a decimal, do you know? 0.2. Okay, so if we were to plot these points, one, 1, 2.5, 10.1. What's going to happen if we went further out here? Like 1 over 100. It's close to 0, but is it 0? 1 over 1,000,000. Close to 0, but is it 0? No. So no matter how big we put the x value in, it never gets to 0. That's what this is showing, that it never touches 0. Now, how would I get the other side of this? This went up. What points could I plug in to get that? This is a 0.11. What's less than 1? Sure. Let's plug a half in. What happens? 1 over 1/2. When you divide by a fraction, you flip it over. This is 1. Flip over the 1/2 is 2 over 1. So 1 over 1 times 2 over 1 is 2. 1/2, 2. What happens if I did 1 over 10? What do you think I'll get? Look at this. I plugged in 1/2 and I got 2. If I plug in 1 over 10, what am I going to get? 10. So it goes higher. 1 over 100, it's going to be 100. It goes up, 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 like that. The negative numbers are going to do the same thing, but on this other side, if we plot all those points. So that's what it looks like. We never get a 0 as an answer. We have a fraction of 1 divided by a number. Can that ever be equal to 0? No. You can't have a 0 on the bottom, and there's nowhere to put anything in to make a 0 on top, so you'll never get a 0. So that's, we can't get 0 as an answer, and we can't plug 0 in. So that's what it looks like. So that's if you were plotting points. But we don't want to do that. Okay, so we're going to just do transformations, move it around. So the steps are these. You find your vertical and horizontal asymptotes, and then you only need 1 point. Why do we only need 1 point? If we know what the graph looks like, it's these two things, then we need 1 point. You draw it, and the other one's a mirror image across from it. So you actually only need 1 point to draw all of this. What if your 1 point was over here? What do you think? It would be here and here, but they're always across from each other. One of them is going to be positive, one of them is going to be negative. Okay, so let's do it. Ready? So I'll just leave a 1 on top for the first example, but that really could be any number. And we're not doing any graphs with x's on top. That's in calculus. You learn how to do those. So you have to use derivatives to do harder rational functions. But you still need this information for asymptotes and stuff like that. Okay, so the vertical asymptote. That's where x can't exist. So what x value doesn't work. How do we find that? It's a fraction, so what can you not plug into a fraction? Something that makes a 0 on the bottom of the fraction. So to find this, you set the denominator, bottom of the fraction, equals 0, and solve for x. So in this one would be x minus 1, gives me 1. So what does that mean? That means on the graph, at x is 1, there's a dotted line. That's what that means. That x can't be 1 because that would make a 0 on the bottom. The horizontal asymptote. What do you think? Instead of knowing anything, what do you think? Kind of like doing our center. This is the y value.
3.
That's it, 3. It's right there. What could we say? It's whatever is added or subtracted at the end, right? That's it. Now, we do need 1 more point, but we're going to do our intercepts because that's what we're usually asked for, and it's usually good to know where it crosses. So if we were to do an x-intercept, we would let y equal 0. This is a harder one. We'll start with the harder one. But this is back to chapter 1. Yep.
So if there was nothing on the end, would it just be
0. So y equals 0, and it would be right on the axis. Yeah, I don't have one written like that, but I'll do that next. I'll add that in. So how do we solve this fraction? What's the rule for fractions? You need a fraction on one side and either a number or a fraction on the other side so you can cross multiply. And there's only 2 terms here, so let's move 1 over. Let's move the 3 over. Cross multiply. So what will we have on the left? Minus 3 times x minus 1 equals 1. There's just a 1 left on that side. And how do we solve that? And minus 3 times 1. X equals minus 2 over minus 3. Am I off the page? Not quite. All right, there it is. What is that? Our x-intercept. X equals 2/3. What's y? 0. Remember to write it down as soon as you find it, because you don't want to look back at that point and think it's something else. That's actually enough to draw the whole graph, because that'll tell you what quadrants that it's in. But let's find the y-intercept anyway. So the y-intercept, let x equal 0. 1 over minus 1 plus 3. So y is 2, x was 0, that's what we plugged in. So we've got 2 points and both of the asymptotes. So you start with the asymptotes because that centers it, how you draw your hyperbola, and then you put it on. Okay. So our x was 1. Here's x is 1. Now this is where people go wrong. They get the intercepts right, or the asymptotes right, but then they draw them the opposite direction all the time. Here's x is 1. Which way do you think is x is 1? Is x 1 here? Still? Yeah. Is x 1 here? 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 These are all x is 1. It goes that way. That's your x equals 1. And then our other one was what? Y is 3. 1, 2, 3. So that goes across the 3 like that. Plot your 2 points. So 0, 2. 0, 2. And 2/3. This is 1, so 2/3 is about here. So they're both in one quadrant, but that's okay. And there's always has 2 pieces. You don't just draw the one. So and then you do the mirror image up here. And that's it. What if you really wanted to plot a point up here to hook it onto something? What would you do? You can always do a table of values. What's the next value over here somewhere? Say 2. And their function is 1 over x minus 1 plus 3. Plug 2 in. What do we get? 4. So this is a point 2, 4. If you wanted a point up there, but you don't need it. Because as soon as you get it on one side, you just draw the same thing across. It's always diagonally across. One's positive, one's negative. That's it, and they don't get harder than that. Like, they're all the same. So it doesn't matter where it shifts around. There's an x and a y-intercept. You can find them both, and you can plot them. So we'll do a couple of these, but you just have to practice them because they really are all just the same. So let's do one with the 0 on the end. All right, so what's step 1 and step 2? Vertical asymptote and horizontal asymptote. Vertical is what? 2, whatever makes the bottom 0. So x minus 2 equals 0 gives me x equals 2. So there's my vertical. Horizontal is what's added at the end? 0. There's nothing there. x-intercept, let y equal 0. Okay, cool. Cross multiply. It's already one thing on each side. We don't have to move anything over. What happens if we cross multiply? It's going to equal 0, right? 0 times anything is 0. What do you think that means? None. So no x-intercept. Y-intercept. You let x equal 0. Why was there no x-intercept, by the way? What was y equals 0? Horizontal asymptote? So it doesn't have a point there because it's an asymptote. Right, it's the dotted line, is that 0? So it wouldn't have one. X is 0. Minus 4 over minus 2. 2. And it's only 1 point, but that's enough because we have our asymptotes and we know the shape. So our vertical asymptote is that x is 2. And our horizontal was at 0, so that's right on the axis. We only have 1 point to plot. So it is what, 0, 2? All right, and that's enough. The graph always looks the same. So how does it go? It's in this quadrant instead, so it goes along each of these, and then the other one is in the opposite quadrant. It seems easy when I do it, and for some reason this is the one people can't get. Okay, so you have to, what do you need to do for all the different types of graphs we did? What's the most important part?
Remember what they look like.
Remember what they look like, because finding a couple points and not remembering what they look like, it's not going to work. So say you did forget what it looked like. What would be your recourse on an exam? What would you do?
Plot more points.
Right, plot more points. Make a table of values, plot some points, right? Because that's a legitimate way to graph. If you kind of know what the shapes might be and you plot a few points, you might get it in the right spot. The vertex is really important, though. If you plot a bunch of points and it's a parabola and you don't accidentally hit the vertex, then you don't have the important part of the graph, right? So it is good to know how to get those points and what the graphs look like. If you're not good at memorizing, then I would start now. The exam is how long away? It's on the 10th, Saturday morning. I'm sorry about the Saturday morning thing. It's my curse. Every year I have Saturday exams. Every year, every term. Saturday night usually, so it's nice it's in the morning. That's a little better. And people do better in math in the morning, so be happy at that. But make sure you eat something. So, the 10th, that's not far away. Today's what, the 16th? I think. Okay, so we could have a number on top. Try this one. Your exams are 3 hours, so 9 to noon. Bring some water with you. Not too much that you have to go to the bathroom. Okay. What do we do first? Vertical. See if you can write it down. And the horizontal. Those two. Write them down. That should just be really quick. X-intercept. Let y equal 0. And then you have to solve that. That's the harder one. And the y-intercept? What do we do for that? Plug in 0. This isn't nice because it's a fraction. You're going to have to find a common denominator and add them. There's the template. That pretty much gives you everything you need. So what's the vertical asymptote? 5, because 5 minus x equals 0 gives me x is 5. So there's my vertical. Horizontal, 2, that's it. Nothing to do, just look at the number. Here, how do we solve that? Move one of the two things to the other side so we can cross multiply. Let's move the 2 over. It doesn't matter which one, you'll get the same answer if you move the other over, but then you'd have a minus 6 instead of a minus 2. Cross multiply. So we will have negative 2 onto 5 minus x equals 6. It's the same every time. Move 1 over and cross multiply. Minus 10 plus 2x. 16 over 2, 8. So 8, 0, 0, because this was the 0 we plugged in. What about this one? 6 over 5 plus 2. We have to do a common denominator. That's like a 2 over 1. So we would multiply it by 5 so that they both have a 5. And then you add the top, 16 over 5. For graphing purposes, what's our guess? Maybe you know it exactly. How many times does 5 go into 16? 3 with 1 left. And what was the decimal for 1/5? 0.2. So it's 3.2, and that's actually exact if you weren't guessing, because it is 0.2. So you could put a real equal sign there instead of a guess equal sign. All right, that's enough. So 0 and 16 over 5. And again, like that's an exact number, and if you knew that 3.2 was the exact answer, you don't need to write the fraction. You could write 3.2. Asymptotes first. So x is 5. And y is 2. And when we're drawing it, we're ignoring this other axis, like the one that we started with. This is the one you're looking at to draw the pieces. So be careful of that too. Sometimes people will try to draw it like way down here, the shape, because they see this line. I'll draw it there because it's not right. You have to draw it along that. Okay, so where are our points? 8 is the x, so there's 5, 6, 7, 8. And this was 3.2 on the y. That was y is 2, so 3 and a little bit. This gave us a point on each of the pieces, which is fine. So this goes that. If I made that dotted line, I could go closer. So what does the 6 on top do? This had like a 6 on top of the fraction. The shape's still the same. What it does is actually moves it farther away from the center. So the ones we did before, remember there was a point that was like 1, 1, so that would be like really close. This moved it out farther. So it just kind of...
Do we have to label our asymptotes? Like,
no, but yeah, they should be clear where they are. So maybe the axis at least, right? But it wouldn't be wrong to label them. It would be okay.
We lose marks if we don't label a point.
Well, if it's not obvious where you drew your line, like, so it's not like just a randomly drawn asymptote, right? Yeah. If you're asked, usually like in a question, I'll say, graph the following. Indicate all important points on the graph. So what do you think that means? I need to see, like, if it's a parabola, I would need your vertex and your asymptote, or in your intercepts. If it was this, I would need to see your asymptotes and any intercepts. Intercepts are an important point, and like a center point, like a vertex or something, is an important point. Okay, so let's just do a couple random ones, sort of to bring it all together of the graphing, the last two sections. That's it for this section. I just put it in a separate section because it doesn't have a vertex. It has asymptotes instead, but that was 2.7. That was it. As I said, 2.7 is like half a class. So here's some graphs. Back to a parabola. So, step one, notice that it's a parabola. So you know what the basic shape is. That's the most important part of any of the graphs. So you know the shape's going to be like this. What else should you think about before you even find any points for a parabola? Whether it opens up or down. And what about this one? Up. How do you know if it opens down? Negative where? In front of the bracket. What if there's a negative in the bracket? No, doesn't matter. Only in front for a parabola. So it's going to look like this. What's the vertex? -3, -16. X-intercept, that's where y equals 0. How did we do this? Yeah, we never actually took the square root of both sides. We did the cube root of both sides when it was a cube, but we never did the square root of both sides. You can do that. Take the 16 over and take the square root of both sides. That will work. The problem is that you only get one answer. And remember, it needs 2 because it's a parabola. We did that with the cube. We never actually did it for this. How did we find the intercepts? We expanded it. That's the safer way. It's not the only way, but it is definitely the safer way. So if you would write out x plus 3 times x plus 3, multiply that all out. Oh, we should put the answer here. So x squared plus 6x plus 9. What do I do when I multiply it out? I just square the first term. To get the middle term, it's you multiply them together, that's 3x, and double it. I don't know if you've heard that before. Because when you multiply this out, you get 3x and a 3x, so it's 2 of them, double. So multiply them together and double it, and then square the last term. X squared plus 6x minus 7. Does that factor? I think it does. Plus 7 minus 1. They multiply to give -7, and they add to give 6. So x equals -7 or x equals 1. So we have the vertex, we have 2 intercepts, and the y-intercept's the easier one. Be careful that you square it and don't multiply. You keep doing that on the test. Every time I put 3 squared on the test, a handful of you write 6. What's 3 squared? All right, what do we do first when we're drawing a parabola? Vertex first, because that's the very lowest point. So the vertex is -3 Negative 16. Let's do that. I just went negative 8, negative 16. Okay, so where does that go? Negative 3, negative 16. And I shouldn't have drawn those points on here because this is the one I find hard to get in the right place. Where does these two cross? At negative 7, 4, 5, 6, 7, and positive 1. So they're going to cross here and here. And this one goes through here. There, does that look even? And remember I said draw it first and then put the points on so that if you don't hit exactly where you had the point, you can move it. Good? So, in your head when you're doing a test, you need words. You need to be able to talk yourself through every single question in math. So what's the first thing you say? Okay, I've got a graph. What's the first thing you say? It's a parabola. So, it's a parabola. Does it open up or down? That might be the second thing you said. So you say, okay, up, because it's plus in front. What's the vertex? Right? And you can't just have blank after you say what's the vertex. What do? What makes the bracket 0, and then what's added or subtracted at the end? Right? You have to walk yourself through the steps. So when you study for math, what you need to do is write the steps beside of every question. And if you write the steps in English or whatever your language is on the side, then that's what will come to your head when you're doing a question on the test. What you don't want to happen on a test is this. Okay, I've got to graph this. Oh, I can see what that looks like. I remember doing one of those in class. What did I have to do again? Oh yeah, I need the point. How do I get that? What's that called? Right? That's not going to work. Who does that happen to on the test? Anyone in here? Yeah. I see you raising your hands embarrassedly, so that's okay. You don't want that to happen. For math, what you need in your head is the steps in English or whatever your language is that you can talk yourself through every question. Not an example. You can't have an example memorized. You can't look through your notes and say, oh yeah, she did that first. Oh yeah, she did that. Oh yeah, I remember that. Oh yeah. That's not studying. That won't help you. You need to actually write down little questions maybe. What's the vertex? Those are prompts. You say, here's a graph. I need to remember what my 7 questions are for this graph. And you have 7 things that you say to yourself. You know, maybe you say 1, 2, 3, 4. Maybe it only has 4. Right? But that's what you have to do for every graph. So, let's see, what time is it? Okay, so let's do a second one. We haven't done absolute value in a while, so let's put that one down. So, you say to yourself, it's an absolute value. That looks like a V. Does it open up or down? Because they're very similar to a parabola. Does it open up or down? How do you know? A negative in front of the absolute value. Just the same as, does this one matter? No. Does this one matter? No. It's just in front of the bracket. So this one's up. Vertex? So you say, okay, what makes the bracket equal to 0? So 2x minus 4 equals 0. So 2. And then what's the other part? The y value. So what I'm talking about saying in English is everything I say out loud to prompt you at every question. That's what you need to say to yourself. You need the prompt in your head. I prompt you because I know what's next, because I know the steps, right? But you have to be able to prompt yourself. So y-intercept, x equals 0. Almost every time I write this down, I say, oh, that's the easy one, right? That's my prompt. Oh, that's the easy one. Okay, we just plug it in. This is easy. I don't need to worry about it. 0 minus 4. Absolute value of negative 4 is 4, because it's always positive. Minus 4. Oh, 0. Okay. 0. That's also an x-intercept. But that doesn't mean we don't have to find the other one, because just like a parabola, it's going to have 2. It goes through usually in 2 spots. So the x-intercept, we let y equal 0. So just like with every other one except the parabola, which we expand to factor or use quadratic, every other one we do this. Put one of these on the other side. So let's move the 4 over. And then we solve. But each one is a little bit different. So with fractions that we did at the start of class, we cross multiply at this point. With a parabola, we expand and then factor or use quadratic. With an absolute value, what do? We say, okay, the inside has to be either 4 or minus 4. To be equal to 4. So 2x minus 4 equals 4, or 2x minus 4 equals 9. Careful with all these 4s, just so I can see a problem. So 4 plus 4, and the other one was minus 4 plus 4. That's the 0, 0 one here, which we already knew, but this is the other one that we needed to find. Does that make sense? Okay, so now we have the vertex, we have the x and y intercepts. What do we do next? Graph it. What do we start with? The vertex. Put your other points on. And it's a V. There we go. So this is exactly like what the test would be. Just one of each question, graph, find the intercepts, that's it. The test on Tuesday. Okay. No time for our last one. So we'll stop there.